Hey, let's talk about trigonometric functions, and let's start with how I got our triangle over here. So I needed a point, which I was given. And to get to this point, I had to travel some units of x and some units of y. So over x units and up y units. And I have my hypotenuse over here, or our r. So let's also label these like this. This is our hypotenuse, our r. X would be considered, well, x and y would be our legs, but x will be our adjacent, and y will be our opposite. And what exactly is it opposite or adjacent from? It's opposite, y at least, is opposite from our angle over here in standard position. And this is how we figure out what sine of theta, cosine of theta, and tangent of theta are. So how do we figure out sine of theta? Well, sine of theta is our opposite over our hypotenuse. So it is our opposite over our hypotenuse. Or it is our y over r, because y is our opposite and r is our hypotenuse. Now cosine is adjacent over our hypotenuse. So it is our x adjacent over hypotenuse. It is our x over r. Tangent of theta is our opposite over our adjacent, or it is our y is opposite over adjacent. So it is our y over x. Now what about our other three? Well, cosecant of theta is just the opposite of sine of theta, or it is the reciprocal, which we would say is r over y. You're literally just flipping it. And secant of theta would just be our cosine of theta, but it would be our reciprocal of it, or the flipped version. It is our r over our x. Now cotangent of theta would be the opposite of tangent. So it would be our adjacent over our opposite, or you could just say our x over our y. For our example, we're given the point 3, -4. And your teacher will word it something along the lines of, find the 6 trigonometric functions of theta if theta is in standard position and the point 3, -4, what we have here, is on the terminal side of theta. So I'm going to go through this like I would go through it in my own head. So what I'm thinking here already is they gave us x. It's 3. They gave us y. It's -4. And we need r to figure out all of our trigonometric functions. Now, I would come over here and I would say, what are my 6 trigonometric functions? They're sine of theta, cosine of theta, tangent of theta, and now our reciprocals. So cosecant of theta is the reciprocal of sine. secant of theta would be the reciprocal of cosine, and cotangent of theta would be the reciprocal of tangent. Now, if you remember, sine is y over r. Cosecant is the opposite. It's r over y. And this is just what I do to remember it. Cosine would be x over r. Secant would be the reciprocal, r over x. Tangent is y over x. And cotangent is the reciprocal tangent, which would be x over y. So first we need to figure out our r. And how we're going to do that is the Pythagorean theorem, which should make sense to you guys, because we know that x squared plus y squared is equal to r squared. So we just plug in our information. 3 squared plus negative 4 squared equals r squared. So this would be 9 plus 16 is equal to r squared. 25 is equal to r squared. It's just basic algebra now. Square root of both sides so that we can get the r alone. Square and square root cancel out, and we're left with 5 is equal to r. So I'll just plug that in up here. So sine of theta, we're just going to fill it in. We have y over r. So we just take our information. Negative 4 over 5. Cosecant is the opposite. We're just going to flip it. It's 5 over negative 4, or negative 5/4. X over r, 3 over 5. Reciprocal for secant, 5 over 3. Tangent, y over x. So negative 4 over 3, or negative 4/3. Cotangent, reciprocal tangent, 3 over negative 4, otherwise known as negative 3/4. Now, how did I know, or what's one way we could have just known that this r over here is positive? Well, r is always positive. Always. No matter what quadrant we're in, r is always going to be positive. So let's do another example. For our second example, we're given the point -2, 3. And again, it's going to be worded along the lines of, with theta in standard position and the point -2, 3 on the terminal side, find all 6 trigonometric functions. Again, in my head, I'm thinking, they gave me x, which is -2. They gave me y, which is 3, and I need to find r. And r is always positive. Now, what are the 6 trigonometric functions I need to find? Sine of theta, cosine of theta, tangent of theta, our reciprocal of sine, cosecant of theta, our reciprocal of cosine, secant of theta, and our reciprocal of tangent, cotangent of theta. Forgot my equal signs. Now, if you can't just remember what these are, what sine, cosine, tangent are, you know, where's the x, the y's, and the r's, I would just draw this out, like a simple graph, just to remind myself. Maybe come over here and figure out what quadrant I would be in. So I had to go negative 2 x units, so I know I'm over on the left half. And I had to go up 3. So I know it's looking something like this. And we're coming from our angle in standard position here. And sine is opposite over hypotenuse. So I can just, I can figure it out from that way, if that makes it easier for you, to figure out that this is y over r. That our cosine would be x over r. Tangent is y over x. And now I just have to do my reciprocals over here. R over y, r over x, x over y. And let's just figure out what r is. Again, Pythagorean theorem. We just have to plug our information in. Negative 2 squared plus 3 squared equals r squared. So we have 4 plus 9 equals r squared. 13 is equal to r squared. Get r alone. Square and square root cancel. And we are left with the square root of 13 is equal to r. And I would put that over here, because I'll look at this information in this box that I've gathered in order to figure out my trigonometric function values. So we'll just plug them in. What's y over r? It's 3 over the square root of 13, but we can't write it like that. Let me go back a second. So y over r would be 3 over the square root of 13. But I can't have this square root in the bottom. So I just multiply by the square root of 13 over the square root of 13. So that I'm given 3 times the square root of 13 is equal to, well, 3 times the square root of 13, and then square root of 13 times the square root of 13 would be equal to 13, because the square roots cancel out when you multiply them together. So we figured that one out. Now what about cosine? Well, cosine will be x over r. So cosine will be negative 2 over the square root of 13. But again, I have to get the square root out of the bottom. So I have to multiply the top and the bottom by the square root of 13. So I have negative 2 times the square root of 13 over square root of 13 times square root of 13. So the square roots cancel out and we're left with 13. So I plug that in up here. Tangent of theta, y over x. Here's an easy one. So 3 over negative 2. Let's do our reciprocals. So the reciprocal of sine, which is y of r, the reciprocal cosecant is r over y. Now I wouldn't just flip what we put in here, because then I would just be putting the square root in the bottom again and I would have to undo it. So I would just come back to our information over here and say, all right, r over y is the square root of 13 over 3. Much easier. Same thing for secant. What is our r? Square root of 13 over our x, which is negative 2. And then for x over y, I would just look over here at tangent and say, all right, let's just do the opposite, negative 2 over 3, negative 2/3. I'll do some more examples in a future video. Thank you for watching. And if you have any questions, please leave them down in the comment section below. If you have any specific problems, go ahead and put them down in the comment section also. And I'll make another video doing that problem you want me to do.